How are AI and robotics transforming how we get everything? Hello and welcome to TechFirst. My name is John Koetsier. There's an invisible but intricate threading through all our cities, states, countries. It's like a human circulatory system delivering pretty much everything we need to live, work, and play. And it's also something that AI and robotics is transforming. Today, we're chatting with CEO of one of the companies leading that transformation. The company is Dexory, and their AI and robotic systems can scan 1 million square feet and 100,000 pallets in a day. The CEO is Andrei Danescu. Welcome, Andrei.
Thanks a lot for the invitation, and it's great to be here. Great to be part of this. Thank you, John.
Great to have you. Let's kick off right here. I mean, you kind of think, hey, I put something in a warehouse. I know where it is. My system knows where it is. I take it out. I know I've taken it out. My database knows that, and it knows how much I have left. But it's not that simple, right?
So in the ideal world, it would be like that, but we all know that we don't live in the ideal world, and there are pressures to get things done quickly. There are time constraints. There are errors that we all make. We're all human at the end of the day. So it's not actually that simple indeed.
I guess there's also pilferage, there's damage, there's just errors of where people put stuff, all that stuff. What does your system do?
So exactly as you mentioned, there's all kinds of errors that you have in a day-to-day operation of a warehouse, in a day-to-day logistics operation. And the technology that we developed, which is represented by Dexory View, works to close and eliminate the visibility gap. And the reason why we call it the visibility gap is because you would like to know everything that's going on in the warehouse, every single pallet movement, how much product you have in every single location, and also things like what are the conditions in which you're storing the good, what the temperature, humidity, how long were the goods there for, why hasn't this location been turned over, or why haven't the goods moved? And that's exactly what our technology does. So Dexory View, it's a digital twin platform. It's a global visibility platform. So you could deploy this across 100 warehouses, and you have one central location where you have access to all the data. And what's really unique about it is that this information that we capture and collect on a daily basis is collected using autonomous robots. So we use this very tall, world's tallest autonomous robot to scan the warehouses, recreate the digital twin, process the information, and make this data available for 100% efficiency and eliminating all the operational errors.
How tall is this robot?
So they're 12 meters tall at the moment, which is
Did
about
you
40
say
feet.
12 meters? Wow. 12 meters tall for our American friends. That's 36 feet, 40 feet, somewhere around there. Did you say
40
that's the
feet.
world's tallest autonomous robot?
It is indeed. And deployed commercially in warehouses, yes.
I'll tell you a little fun fact about myself. When I was in university, I had a lot of different jobs. One of them was actually installing racking in warehouses. So you'd be up 12 meters, handling all kinds of beams and everything, putting them together, welding them, all that stuff. It's a little high.
It is. And people have even higher warehouses. We are maybe secretly working in our deep tech labs on even higher robots, of course. But
Maybe secretly.
I wouldn't know. I'm not allowed in there. But exactly like you said, the robots were designed specifically for this application, for acquiring data. So obviously we made them as high as the racking, so you can scan the entire warehouse in one pass.
Andrei, tell me a little bit about the robot. How does it scan? What does it use? How many sensors does it have? All that stuff.
So I'll try and keep this relatively short because we don't have all day, and I would love to speak about this technology.
We
all
have
day.
like 500 hours. You can take as much detail.
That's a good tease. I might actually carry on forever. So like I was mentioning, we designed the robots specifically for this application. So for data collection in warehouses, it's designed to operate fully autonomously, which means you don't have to make any kind of warehouse infrastructure changes. You don't have to put markers. You don't have to change the space. None of the space interaction. But also very importantly, It's designed to operate during normal working hours, during the night, during the day, whenever you want to be taking scan. Of course, on the bigger sites, like we were discussing, 1,000,000 square feet, over 100,000 pallets, it does take, 22, 24 hours to scan and turn that around. So
Mm.
it is literally designed to operate during any type of conditions as a collaborative robot, integrating with the existing workforce.
So how does it scan stuff? What sensors does it have? Obviously some visual sensors, but I'm assuming more than one.
It definitely has more than one. So in order to scan everything at this speed, we use the autonomous systems on the robot to do the digital twin reconstruction. So the robots operate 3D SLAM. We have our own development of 3D SLAM to be able to navigate the environment. And then we use additional LiDARs and we use additional cameras to reconstruct the digital twin. When we say digital twin, obviously we're focusing on the racking and the rack location side of the warehouse. So it's not so much about reconstructing the building for the sake of having the building, but more about what is actually going on in every single one of these locations. So we have 6 LiDARs. We have one camera for pretty much every single rack row. So if you have 12 rows, you'd have over 12 cameras, because we have additional cameras to be able to perceive the environment better. And we also have other sensors, like I was mentioning, temperature, humidity, environmental conditions, the amount of noise, the amount of light, the capabilities of the existing network infrastructure, because that's another really big thing. You would probably know this from building racking, like you mentioned, but if you have a 12-meter, 40 feet high rack, and you go and scan something in location, and then you are out of Wi-Fi coverage, and then your handheld scanners don't work, it is a problematic area for that warehouse operators to be able to do their jobs better. And the technology is really all about eliminating these gaps and creating a very efficient work environment.
Super interesting. So 12 cameras, is that per side? Can you scan both sides as you go down an aisle?
No, we are focusing on one side at a time. So
Mm-hmm.
the scanning speed that we can achieve, we're scanning over 10,000 pallets an hour. So from that point of view, it is incredibly fast. In that deep tech secret lab that I mentioned, I'm not allowed in. We are working, of course, on higher scanning speed. But the main reason why we do this is you have a large variation of warehouse layout. So you could have very narrow aisles, you can use VNAs, you can have wide aisles. It's quite difficult to always be able to center yourself in the middle. And also, navigating down the middle can impact operations because you're kind of eating up a lot of space. Whereas if we're going very close to one face of the rack, there's a lot of space around the robots for people to actually carry on doing their day-to-day activity.
That makes
So
sense.
that's the reason and the choice why we're only scanning one side at a time.
That makes sense. That's interesting. Now, if you're going 12 meters up, you can't be just some skinny little robot at the very bottom. Otherwise, you'd be very tippy. So what are the dimensions kind of on the ground floor?
So currently we're just under a meter wide and about 1.5, 1.6 meters long as the overall footprint of the base. And the reason why we made it so narrow is it's actually designed to fit very narrow or the narrowest VNAs. In VNAs, it's actually very important because it's also one of the more difficult parts of the warehouse to actually acquire any kind of information because the lanes are narrow and you don't even see with your eyes out all the way to the top.
So correct me if I'm wrong, those are the types of warehouses and the racking that is completely automated, that there's robotic pickers and other things like that going down very narrow lanes. Is that correct?
No, actually not entirely. So you can have automatic storage and retrieval systems, which are usually very tall. They're up to 30 meters and then 40, 50, 60 meters deep. But these are the ones where you have a crane that puts the pallets and retrieves them. But that's not what I'm talking about. I'm talking about standard racking, which is quite close to itself. And
Yeah.
usually you have this narrow forklifts, which
Yes.
select the pallet, but they're still traditional forklift with human operators.
Okay. Interesting. Now, the base of the robot, do you weight that so that it's heavy at the bottom so that you've got stability?
Yeah, absolutely. So by design, it's very, very bottom heavy. because of course it needs to support, exactly like you said, the entire height of the robot.
Mm-hmm.
So we are talking about 700 kilos and center of mass, which is below 40 centimeters from the ground.
Wow.
So yeah, for
Wow.
the overall product weight, it is indeed very, very very bottom
That
side.
is super impressive. And you mentioned, like, you got this 100,000 square foot warehouse. It's funny how we're talking in meters for height, about 100,000 square foot for square feet for the warehouse. But hey, this is the real world. People use different dimensions. And you mentioned scanning that in 22 hours, 24 hours. Can this robot change its own battery? What does it do when it's out of battery?
So just a quick one, because you actually hinted 100,000 square meters or 1 million square feet. Right. Whichever, we can do whichever
Oh, I
dimensions you want.
misheard you. 100,000 square meters. That's a different
Yeah,
matter
yeah,
entirely.
that's so 1 million square feet is what we were mentioning.
Ouch.
Yeah.
Excellent. Okay, so we're gonna need battery power here. We're gonna need to recharge. How do we do that?
So it's completely autonomous in terms of looking after its state of charge and after its battery. So very similar to household robots. So the Roomba we have, or any other devices we would have in our house, would know when the battery is getting low, and then find the dock and recharge itself. We have a very, very similar setup. Of course, the robot has a docking station as a permanent area where it's actually charging and usually kind of waiting until it's ready to do the mission. And when it's actually getting low on battery, it will navigate itself back to the charging dock, back to the dock, wait for the batteries to recharge, and then carry on from wherever it left off. So it knows at every single point in time how much power it has available for scanning.
Is it a fast charge battery? That would probably be critical if you've got a lot of work to be done. How quickly does it charge?
So I wouldn't class it as a fast charge battery. In all honesty, it doesn't charge at huge currents, and it doesn't charge in 15-20 minutes. It takes about 2 hours for it to charge, and it can
Mhm.
operate around 5-6 hours on one battery charge.
Okay. Okay. Interesting. And I guess if you needed more, then you buy more machines, or actually you don't buy them. It's a subscription model. Or perhaps eventually in your super secret lab that the CEO is not allowed into, maybe there's hot swappable batteries being worked on. Who knows?
I don't know. I wouldn't be.
Never been inside.
I don't even know the location.
Exactly. This is Apple level security times 10. Wow. Excellent. So talk about some of the results of this. Obviously, I focused on the robot. There's obviously a software system here as well. You mentioned digital twin, recreating the physical warehouse in a virtual sense and giving you a sense of what's all there, probably integrating with the warehouse management system, all that stuff. When you do that, when you're in operation, what do you fix? How do you improve stuff? How much better is it?
So that's everything you mentioned. Very, very good point from a point of view of the software platform is really what customers interact with. The robot per se is a means to an end, is the device, the machine we've actually built to acquire the data. It processes the information locally, and then the insights get sent over to Dexory View. This software platform is where customers can log in, can have the complete overview of their operation of their warehouse. They can also start seeing analytics. Once you run the technology for a couple of weeks, you start observing trends, you start having an understanding of how the space would evolve over time. Now, I can tell you that we've started working in warehouses where the overall efficiency was even below 90%, which is low for a warehouse, especially for a big space if you think about it. And within 1 to 2 months, we've managed to take that efficiency to exceed 99.56%.
Wow.
So what's really impactful is the fact that you can supercharge your existing teams. Like the big problem in logistics that people have at the moment is that there's a massive labor shortage. There's an increasing pressure from customers to have everything delivered yesterday. And of course, there's pressure in terms of margins, in terms of operational efficiency. And of course, when you bring all this together, it's really hard. You can't just keep aspiring to hire more people because your problems are not going away magically. So
Hmm.
bringing this technology, closing the visibility gap means that your existing workforce can actually do more in their time. You can, first of all, you eliminate a lot of the errors almost completely remotely, because you can look through the platform, see the pictures, see the quantities of stock you have, make all the changes without even having to set foot in the warehouse. And if you still have a couple of locations that need physical manipulation, or you actually want to change where those goods are located in the warehouse, it's much, much easier to be very targeted and know exactly, okay, you need to go in this place. This is where the pallets are located. I want you to move these goods. I want you to distribute them. They need to be closer to the picking phase, and so on and so forth. So it literally supercharges your existing workforce to do 10 times more than they could do before.
Well, it makes a ton of sense, right? Because another job I had while I was in university was working in a warehouse. It's amazing. Built them and worked in them. Who knew students needed money? And yeah, I mean, we waste a lot of time trying to find stuff. It's in this bay. No, it's not in that bay. Well, maybe it's in the other bay. Who knows? I didn't even know if there was a warehouse management system then, back in the dim mists of time past, but who knows? Anyways, I can totally see that. How do you, two questions. First one, how do you measure warehouse efficiency? What does 90% mean? What does 99.5% mean?
So that's definitely an interesting question, because it does vary a lot. Because different warehouses have different KPIs, and they're targeting different areas of improvement, or different areas where they're measuring. So if you take one example, a pharma warehouse, where the product that you're keeping in there needs to be in very, very well controlled conditions, or well monitored conditions. Maybe they're not controlled, but they need to be very well monitored. The inventory needs to be in the exact location where you think it is, because otherwise you might be storing the type of drug in a completely inappropriate overall environmental condition, and so on. So, inventory accuracy, product location accuracy, occupancy, so product volume in every single area of that warehouse become some of the driving KPIs. Because if you have a pallet of drugs, for example, and they're very, very expensive and very rare drugs, and they're being sort of like misplaced, and then they get lost in the warehouse, it literally impacts it triggers a whole chain of events and impacts a lot of people further down the line. So being able to go in the review and say, okay, I'm looking for this pallet, you will type the pallet number, and it shows you exactly where it was detected, whether it's in the right location or not. It will find it for you in the warehouse. That drives a huge amount of impact. And then some of the other warehouses, where they maybe have different velocities of goods, but different volumes, much higher volumes, for example, they want to be able to store as much product in the same space as they can. So for them, utilization becomes really, really important. So one of the big drivers from KPIs and performance drivers from Data Review is, how well are you actually utilizing, how well are you storing and occupying your existing space, your existing racks? And
It makes a lot.
we only have 500 hours.
Exactly. Makes a lot of sense. Absolutely. Now, what kind of AI are you using? What kind of vision are you using, technology there, to know what you're seeing? You mentioned a pallet number. Okay, you can see a pallet number. That makes sense. Are you scanning a barcode? Are you looking at an object and saying, this is what I think it is, or it's of this size, or other things like that? What are you doing?
So we're using a combination of techniques there. I don't think it's like a one size fits all. You only have to use one specific thing, and that's the magic formula. You can apply it to everything. It's a combination of machine vision technologies for barcode scanning, QR code scanning, for character recognition, which then gets coupled and sensor fused with other types of perception to understand, I'm looking at 5 boxes or 6 boxes, or I'm looking at this specific type of product. It's a
Mhm,
big problem, because in a warehouse, you have a lot of boxes. So you don't
mhm.
necessarily have an easy time knowing what's inside them, which is why you have to have a combination of perception systems, of algorithms, like I said, a lot of machine vision technologies to do that recognition. We then have different types of perception to understand, okay, I have this product, I have these boxes, then I look at my cloud points, I look at the 3D reconstruction to say, this is the volume that they occupy, this is what I'm scanning, this is how much product I have on the shelves. And this is where the more advanced AI technologies come into play, allowing us to really go deep inside the data sets that we're gathering. So you can scratch the surface, and extract the superficial stuff around, reading barcodes and positioning those barcodes in space. But then when you start building these big data sets and you start using more advanced sensor fusion techniques to bring multiple sources of information together, it really allows you to go deep into that data set and bring more value to customers.
Interesting. And that data somehow has to make its way into the warehouse management system, I assume, which I assume also that you are not the warehouse management system, although you feed data into it. Is there some sort of like progressive ETL or something like that to build up that, kind of digital twin in data in the warehouse management system so it's continuously aware of what it has where and all that sort of complexity?
Yeah, I mean, that's a very, very good point to touch on. Of course, the warehouse management system is an fundamentally open-ended system. It relies on data being pushed into it. And that's one of the reasons why we decided to build this robotic technology, is to really acquire the data, the ground truth, what's actually happening on the warehouse floor. We can integrate with any warehouse management system. Most of the systems have APIs. Our system, Dexory View, has its own set of APIs, so you can pull data or you can push data from WMS systems. And what's really interesting for Dexory View is the fact that it allows us to bring data from multiple types of warehouse management systems. So we can create this single source of truth for the entire warehouse. But exactly like you said, it's very, very important not only to be able to pull data, but also to do a two-way data exchange with pretty much most WMS systems in the market.
Makes sense. You don't sell your system, you sell a subscription to it, correct? How much would it cost?
Oh, asking the secret questions, all the secret questions.
Is that also in the deep secret lab?
No, that's in the secret folder that doesn't live in the lab. It does really, really depend on the type of warehouse, primarily on the feature set that you select, right?
Mm-hmm.
So the business model, exactly like you said, is a pure subscription to the platform. So similar to most modern ways of utilizing software. We will then look after the hardware, make sure that the robot's always operating to provide that data stream into the platform. But in terms of the pricing model, it does depend on what we're looking in terms of the feature set, what we're looking in terms of the advanced functionalities, if there are customizations that are specific to any location or any type of customer that we want to go into.
Mm-hmm.
What I would say is the value that the system brings greatly exceeds 10, 11 times the price that you pay. So the ROI is really, really good.
Anybody with a warehouse would be a fool not to have it. Is the way.
You said it, I didn't, but I couldn't actually agree more.
Look,
Now, but
well,
I think, it's a good point, and we can build just a little bit on that and say, at the end of the day, in today's world, you have to be able to bring new technology into the market, and you have to give people the confidence that this technology brings the ROI they need. Because it's not about buying something, it's about bringing that service that really drives value for the locations.
Well, and we chatted about this a little bit before we started recording as well, right? I mean, I've been doing a lot of stories about drone delivery. And we know that Google's Wing is doing that. We know Amazon is doing that. There's a bunch of other there's many other companies. Mana Arrow is doing that. It's happening in the States. It's happening in Europe. It's happening other places as well. Asia, I'm sure. And as you enter that world, you're entering a world in which the 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 amount of time that a product is at rest versus the amount of time it's in motion, that's decreasing. I mean, it'll stay less time. You have this continual flow, right? And something may be in the warehouse for 7 minutes, not 7 days, right? And there it goes. So you got to be really sure about what you have, where it is, how to get it, how to access it, how to get it out, how much you have left, all that stuff as that pace increases, correct?
Absolutely correct. And I think connectivity is one of the most important elements of that puzzle as we're building that future of fully autonomous deliveries and this global visibility across our supply chain.
Interesting. Autonomous delivery, autonomous warehouses, autonomous production, autonomous everything. Um, Excellent, Andrei. Thank you so much for this time. I really do appreciate it.
It's been a pleasure, and hopefully we speak again soon, and I can tell you some of the secrets. I am going to try and find that secret lab.
I'll parachute in at night, a James Bond style, or we'll
You
see.
don't know the location, though.
I have my ways.
Perhaps.